All right, so continuing that worksheet here, again, I want the worksheet submitted. Please follow along with me. We'll get a lot of this solved here. So we've got here, Kim picks peaches last summer. Her potential earnings are in the table. So now they just kind of, it's very much like the first question. Notice it's $1.50 increase every time. As she picks more peaches, baskets of peaches, I should say, she gets $1.50 increment each time. So that means the rate of increase here, the rate of change here, is going to be $1.50. Okay, so you've got $1.50 increase all the way down with this question, right? $1.50, $1.50, $1.50, $1.50. Okay, so it's the same sort of question. I want you guys to go ahead and answer 3 on your own. You can come back to that. It's almost exactly like, obviously different variables that you're going to introduce, but it's very much like part 1, right? It's going to flow very much the same as the first question. Okay, so I'll let you guys do 3 on your own. Create your equation, find the slope, all that sort of thing. For 4 here, let's do 4 together. You've got this guy here. He's a truck driver. He's making 45 cents per kilometer that he drives. Right away, we already know, okay, per kilometer, that means per 1 unit. I know that. So because that's the rate of change, okay, I can calculate my earnings. All right, obviously, I drive no kilometers, I get no money. If I drive 100 kilometers, I'm going to get 45 cents per kilometer. That's going to be $45. Well, if I drive 200 kilometers, again, I'm getting 45 cents per kilometer. I'm getting $90. Drive 300 kilometers, you multiply these two out, you're going to get $135. And lastly, if I drive 400 kilometers, since I'm getting 45 cents per kilometer, by multiplying those two together, you're going to get here $180. Now, notice here what happens here. If I go to calculate my rate of change, it's going to be the bottom minus the top here. So in this case here, the rate of change is 90 minus 45 is 45. 90 minus 45 is 45. 90 minus 45 is 45. So for the rate of change here, I'm not getting 45 cents, I'm getting $45. And the reason for that is because you're not doing your step actually isn't per kilometer, it's per 100 kilometer. You'll notice here. So the rate of change I'm finding is $45 per 100 kilometer, which is equivalent to being 45 cents per kilometer. Okay, this is really your rate of change, but a lot of times, depending on the question, you want to express your rate of change in a larger unit of measurement, right? If you're talking about a truck driver who's going to be driving 400 kilometers, you don't want to be measuring it in per kilometer. You want to break it up into per 100 kilometer. It would make more sense. Okay, so if we go to graph this here, and let's do that. Okay, on the bottom here is number of kilometers, and the top here, let's label this my earnings. I'll put an E for earnings. Okay, we need a little more space here. I'm going to put an E for earnings. Okay, so number of kilometers here, let's go 100, 200, 300, 400. Earnings, let's go 45, 90, 135, 180. So now if I go to plot these values here, you can see you have your linear equation. And I missed that one there. Let's get that. Okay, there we go. Okay, and you'll notice here, right? 100 kilometers is $45. 200 kilometers, you made $90. 300 kilometers, $300. And lastly, 400 kilometers, you made $180. Okay, we've got E stands for your earnings. And then in this case here, maybe we'll let K be the variable here to stand for number of kilometers driven. So determine the slope of the equation. Well, to find the slope of the equation, you pick any 2 points you want at all. Okay, I'm going to pick these two here. Now, my rise here, the distance from here to here is not 2. You have to look at the units. This is 90, and this is 45. So the difference between those two is 90 minus 45 is 45. And the difference from here to here is not 2. It's actually 100. And in this case here, that's my rise, and this is my run. Excuse me. So if I go to calculate my slope here, as they're asking, my slope here is going to be my rise over my run, which comes out to be 0.45. And this is measured in dollars per kilometer. Okay, so you'll notice here, they ask you to go ahead and you graph it, and then when you go ahead and calculate your rise over run, you get that rate of change that we found originally in the question. Okay, oh, in part A, they ask you to determine the equation. Let's just do it right here. The equation for this is going to be what? Well, E is my earnings, and I'm making my rate of change, which is 0.45, times K, the number of kilometers driven. Okay, that'll always be the form. As you guys know from grade 9, these linear equations follow this form, y equals mx plus b. In this case here, the m was my slope, but when you talk about word problems, you kind of change the word slope sometimes to rate of change. They mean the same thing. A rate of change is kind of relating to your fact that it's a word problem now. And your b value is your y-intercept, or also known as your fixed cost, or fixed value right here. So in this case here, there was no initial cost or fixed cost with this question because you weren't getting paid. Like if they would have said in the question, okay, the truck driver gets $50 for the day plus 45 cents per kilometer, and then we can change, this would be a 50, right? And you'd have to tack on to this equation of plus 50. But it wasn't the case here. They're just getting a flat pay of 45 cents per kilometer they drive. Okay. Number 5 here, I'll get you guys going on 5. I want you to do that on your own. Grace has a bank account she rarely uses. On the last day of each month, the bank charges $5, okay, as a service charge for managing the account. On January 1st, Grace had $67 in the account. She made no deposits or withdrawals in this account. Create a table of values to represent the money. So you'll notice here what's going on is this person has a bank account they're not really using. So every month they lose $5 in service charges. So this person started off with $67, and then you subtract 5, you're down to 62. Then we're down to $57. Then we're down to subtract $5 back to $52. And then another 5, you're at $47. Then another 5, we're at $42. And lastly, we're at $37. Okay, and the question becomes, what's the rate of change? Well, again, when you go ahead and calculate this, you guys are going to find you're going to take, and again, when we do our rate of change, we do your rate of change here, we're going to go 57 minus 62, bottom minus top, bottom minus top. Now what comes out here, you get 57 minus 62 is actually negative 5. Negative 5. Negative 5. Negative 5. And the reason why it's negative 5 is because this is a decreasing relation. You have a decrease in the values here. Notice the values start at 67, you go down to $37 in 6 months. Whereas a previous question, you'll notice your earnings are increasing, increasing from 45 to 180. That's why the equation was increasing as you read it from left to right. That's why my rate of change was positive. Likewise here, you're going from $1.50 to $9, right? So those equations were increasing, so you had a positive rate of change. For these ones here, they're decreasing values. So when you guys go to graph this, the line should be going downwards. Okay, so finish up 5, and then we'll meet up and discuss this further.